recording. There we go. All right, everyone. So, welcome to our Math 171 Elements of Pre-Calculus review, namely for the departmental sample final. This is being presented by the MS3 Center. When this meeting is over, it just takes us a few hours, just because the video file is going to be very large. It's going to take us a couple of hours for us to get this uploaded onto our website and onto our YouTube page, right? Our YouTube page is going to be, I send the link there onto in the chat. Unfortunately, if you're here for Math 132, you missed the meeting because the meeting was technically at 10 a.m. So I'm sorry for the confusion there. Today, at this time, at 1 p.m., I'm going over elements of pre-calc.
Oh, can I ask you a question?
Yeah, go ahead.
But in the email it say 1 p.m.
I understand there was a misconception there. It was a typo on that email.
Oh, okay, I understand now.
Yes, I'm sorry about that.
It's fine. Can we get the video right now or later on?
You have to wait, ma'am. I'm sorry.
Oh, okay, it's fine.
Yeah, it's just that it takes, like I'm trying to explain, it takes a while for us to get those video links. I just can't directly send it to you. We post it onto our website, and then we post it onto our YouTube channel. So it just takes some time. All right. So, like I said, if you're here for 132, I'm sorry, but I won't be going over the 132 stuff. I'm going over Math 171. That was the original plan. Okay, so problem number one on your sample final, what I had to do was create your sample final, by the way, your instructors probably gave it to you or it's on your website. But here are as I go through each slide, these are the problems on the 171 sample final. So problem one states, let f of x equals to x plus 5 and let g of x equals to x squared plus 5x. Specify the domain of f over g. So when I have one function divided by another, f of x divided by g of x, what do I know about that denominator?
You both have the x.
Yeah, well, yes, there's going to be an x involved, but more importantly, what do I know about x, right? When you talk about a domain of a function, sometimes the function's domain could be all real numbers, or sometimes you can have problematic inputs. If you have problematic inputs, it's whenever what's equal to 0. Well, I just said it. I gave it away. It's whenever g of x is equal to 0, right? So again, your denominator, you have to exclude values of x that makes that bottom 0, right? Whatever values of x makes the denominator 0. So let's write out our function. So if we have f of x over g of x, then this is simply x plus 5 divided by x squared plus 5x. Okay? So there's going to be values of x that makes this bottom 0. And one way that we can tell what values of x makes that bottom of 0 is to rewrite the denominator in factor form. If you rewrite the denominator in factor form, x squared plus 5x, then what would be our denominator in factor form? That's right, Preston. You get x times x plus 5. Okay, so for what values of x now would make that bottom 0?
-5.
-5 is one possible value. What's another possible value? Is 0. That's right. In other words, you just take the denominator, x times x plus 5, you set it equal to 0, and you solve for x, right? You get x equals 0. That's one possible solution. And if you have x plus 5 is equal to 0, then x, if you subtract 5 on both sides, then x is equal to -5. So those are your two problematic inputs. Other than that, you don't have any other problematic inputs. So in words, your domain of f over g, right? F of x divided by g of x is all real numbers except when x is equal to 0 and x is equal to 5. Now, some instructors will accept the domain in real numbers.
I'm sorry for interrupting you. Match
Go ahead.
something. So in the final exam, you're gonna be the same question but like different numbers or different question type of thing for the first one.
The final exam, it depends. I think for Math 171, the instructors created your individual instructors. For 172, usually, I think your instructor also creates that one. Usually when they create the final, it mimics the sample final of the department. See, it's departmental sample final. So when you take the final, it mimics what you see here. All right.
I have a question.
Excuse me, sir.
I didn't get to finish this problem, by the way, so let me just
Oh.
finish this problem and then I can take your questions. So that way we don't lose our train of thought. We have our domain of f over g is all real numbers except when x is equal to 0 and x is equal to 5. So if that's our domain in plain English, how can I express this domain in interval notation?
Parentheses 0, comma, -5.
Nope.
It's not parentheses, negative infinity, comma, 0, union. I forgot the other one.
Well, sorry, this is supposed to be x equals -5 here. So you start with the -5 first because -5 comes before 0 on the number line. So it's negative infinity to -5, union, like you mentioned, anything between the -5 and 0, union 0 to infinity. And that's it. That would have been the solution. Either one. The first one is in words. The second one is in interval notation. Okay, now I could answer some questions. What questions do you guys have?
Okay, I have a question.
Go ahead.
For this specific question, for this specific problem, could we just say like x equal to 0 and x equal to 5 and that's it, or we have to still do the
No, you cannot say x is equal to 5. X is not equal to 5 in this problem.
-5. I'm sorry, -5.
X is equal to -5. Yes.
Yeah.
Well, no. You have to say, you have to talk about what is exactly your domain. You see, x cannot be equal to -5 and 0 because they're problematic inputs. And because they're problematic inputs, then you cannot divide by 0, right? -5, if you plug that in, you will get a 0 in the denominator. That's no good. If you plug in x equals 0, then you're still going to get 0. It's no good. So those are the two values that you have to exclude from your domain. Your domain now is everything else. Domain is everything else. It's all real numbers, but these two specific values.
I have a question. So those two like specific values make the denominator equal to 0. So that's why we exclude them, right?
That's right. That's right.
Okay.
If you want an extra reinforcement here, you can draw a number line. All right, here's all the way negative infinity. Here's infinity. Let's say 0 is at the center, and let's say -5 is closer to the 0. Then when I look at my number lines perspective, I can draw an open point at 0 and -5 and show that I include everything else. I can include anything else.
Okay, I get that. Yeah, I get that. That's clear.
All right.
Okay, yeah, for this problem, like we always have to like simplify the denominator, right?
No. Does it say simplify anywhere? Does it say the word simplify?
Mm-hmm.
I'm asking you,
No.
do you see the word simplify?
No.
No, so there's no need to simplify. You can, but that's just extra work that the problem is not asking you to do.
Okay. Or factor, I don't know, like
Well,
yeah,
factoring is different from simplifying. I just said we're going to factor it
Mhm.
completely, but you don't simplify. It doesn't say
Okay.
simplify.
Okay.
All right? So,
But for this
go ahead.
question, should we like put the interval notation too on the right side, or
Well,
we're only
did I not write out the interval notation here? I
yeah,
did.
you wrote it, yeah, I did.
There
so
you
yeah.
go. I mentioned it earlier. Depending on your instructor, they either accept it in words or interval notation.
Professor, could you do one more, a different example, please?
I'll do that Wednesday. If I do another example, then I won't have enough time to get through the whole sample final. But
Copy.
You should look back into your old homeworks. Do you do homeworks on MyLab?
I do.
Well, you can look back at the old homework assignments and retry similar problems until Wednesday. Right? Almost all the problems here that are on the sample final, you can find them on MyLab through your homework assignments. Okay. Any other questions with problem 1?
I have a question.
Go ahead, Amin.
So I'm just curious, how did you go from the how'd you get the x in parentheses x plus 5 from x squared plus 5x?
I just factored. I factor out the greatest common factor, which was x.
Oh, because they both contain x, and then
That's
you were
right.
left with x plus 5.
Mm-hmm.
All right, I just was confused for a bit.
All right. What you're going to see is a little bit more factoring soon. Any other questions? Okay, on to problem number 2. Problem number 2 states that we want to simplify a complex rational expression. How do I know that it's a complex rational expression? Well, if you look at your numerator contains fractions, and your denominator contains fractions. So it's a complex rational expression. Now, the way that I go about simplifying complex rational expressions is by clearing your denominators, right? Namely, I want to clear the x minus 6, I want to clear the x plus 6, and I want to clear the x squared minus 36. In order for me to clear the denominators, I need to find something called the least common denominator, okay? So one way that can help us to find the least common denominator is to write out everything in its factor form. For example, the 4 over x minus 6 is already in its factor form, and 4 over x plus 6 is already in its factor form. There's nothing I have to do with them at the moment. Just leave them the way they are. So I have 4 over x minus 6 minus 4 over x plus 6. Now you're dividing all of this by 8 over x squared minus 36. Now you can factor x squared minus 36, right? X squared minus 36, when you factor it, is going to be what?
X plus 6, x minus 6.
There you go, Yasmin. You get x plus 6 times x minus 6. Okay, so now I have to find the LCD between these three denominators, right? Find the LCD of x minus 6, x plus 6, and x minus 6 times x plus 6. Well, what do you think will be the least common denominator between these three expressions?
X minus 6 and X plus 6.
Yes, that's correct. You see, the denominator, in your denominator, you originally had 8 over x squared minus 36. You found that when you write it in its factor form, the denominator is actually x plus 6, or 8 over x plus 6 times x minus 6. And if you look at the numerator, the numerators, denominators, which were x minus 6 and x plus 6, were part of the factors of x squared minus 36. So therefore, your LCD is simply x minus 6 times x plus 6. All right. Now, just remember, whatever I do on one side of the fraction, I have to do on the other side. Namely, if I multiply our LCD in the denominator, then I multiply the LCD in the numerator. When I multiply everything by the LCD, I'm multiplying the individual fractions by our LCD. Okay, so what this will look like is the following. I'm going to take the 4 over the x minus 6. I'm going to multiply that by x plus 6 times x minus 6. The other fraction, which was 4 over x plus 6, again, I'm multiplying it by my LCD, x plus 6 times x minus 6. And again, I'll do that in my denominator. Now, by doing it this way, I'm capable of clearing out my denominators. For example, if I take x plus 6 times x minus 6 and multiply it by 4 over x minus 6, something can be canceled out here. What can I cancel out?
X minus 6.
There you go. I can cancel out the x minus 6. So, Mateo, if I cancel out the x minus 6, what do I have remaining?
You have x plus 6 times 4, right?
X plus 6 times 4, or you write it out as 4 times x plus 6. There you go. All right, let's look at the second fraction. The second fraction, 4 over x plus 6, when I multiply it by the LCD, x plus 6 times x minus 6, what would that be?
The x plus 6s would cancel, right?
That's right, your x plus 6 will cancel. So I'm left with negative 4 times x minus 6. Now let's look at the denominator. The denominator, if I take 8 over x plus 6 times x minus 6 and multiply it by our LCD, what can we cancel out?
X plus 6 and x minus 6.
You can cancel out the x plus 6, and you can cancel out the x minus 6. So what are we left with?
With 8.
We're left with the number 8. Okay,
Yeah.
good. So if you notice, after I found the LCD, which we got was x minus 6 times x plus 6, we multiply everything by the LCD, and that allows us to clear the fractions, namely the complex part of the fractions. Now, this problem becomes something of just simplifying. So in order for me to simplify this, I have to distribute the 4 and the negative 4 first inside the parentheses. So if I take 4 times x plus 6, that's 4x plus 24. If I take negative 4 times x, that's minus 4x. If I take negative 4 times negative 6, that's going to be a positive 24. All right, now we just combine like terms in the numerator. So if I take 4x minus 4x, what would that be?
0.
0, so that's canceled out. You got 24 plus 24, which is
48.
48,
48. And 48 divided by 8 is,
6.
and that is your solution. You get back an actual number. So, Christopher, I know you're going to probably ask this question, so I'm going to answer it. You might ask to see another example. I'm going to hold off on that. We're going to do other types of examples on Wednesday. Okay?
I'm good with this one.
All right, you good? I'm going to show you another one. I'll show you another one Wednesday. Because you see this one here, if you look at it, when we simplify it, our end result is just a number. Sometimes when you simplify it, you can actually just get back an irrational expression again, just a algebraic expression. So another type of example I'll show you next time, all right? That'll be
Gotcha.
Wednesday. All right, anybody else? Any questions here regarding problem 2?
So the first step would be to.
I can't hear you, Amin. Can you speak a little louder to your mic?
Okay. I said the first step would be to.
I'm so sorry, I can't hear you. So sorry, Amin. I can't hear you through your mic. It was a lot of grumbling going on there, so I couldn't hear you. Maybe you want to type it out in the chat real quick if it's a short question. Ah, you're in an airplane. No? If you're in the Math 170 class, Mateo, you will have, I think 16 problems, but in 172 it's 18.
Okay, thank you.
Sorry, I'm just answering a question in the chat. Okay. Yeah. So the first step is, yes, your first step is to find the LCD. Once you find the LCD, you multiply everything by the LCD, clear your fractions, and then you continue to simplify. Alrighty. Okay, let's continue. So, problem number 3 states, draw the graph of y equals the absolute value of x minus 2 plus 4. Now, the only way that you will get credit for problem number 3, or the full points for problem number 3, is if you graph this function using transformation. So, well, since we have an absolute value here, what does the graph, or what would the graph look like? What type of shape?
A V.
Yeah, the shape should resemble a V. Okay, so we know that for the absolute value, it resembles a V shape. And now we just got to use methods of transformation to help us make our sketch. So let's dissect this. I already know it's a V shape. If you look at inside of the absolute value bars, you have this minus 2. So that minus 2, does it tell us that we're going to shift to the left, to the right, up, or down? What does the minus 2 indicate?
We're gonna shift to like, I think it's like left or right because it's x, right?
Well, no. Well, you said left or right. It's one or the other.
I mean, it's definitely left then. 'cause
Right.
it's
It's right. You shift to the right. So you're shifting to the right. by 2 units. Okay, so we know that we're going to have to shift to the right by 2 units. Now let's tackle the plus 4. The plus 4 is on the outside of the absolute value. So what does the plus 4 tell us?
That it goes up by 4.
Yeah, it goes up by 4.
It goes up by 4. That's right, it goes up by 4. So we shift up 4 units. All right, now, is there any reflections here?
No.
Nope. So we'll just indicate no reflections. So because there's no reflections, then our general V shape just stays the same, right? It's just going to look like a V. It's not going to be an upside down V. It's not going to be a side, like a rotated 90-degree V shape. It's just your standard V. All right, so we make our sketch. So here's our Y-axis. Here's our X-axis. So we start at the origin. That's usually the anchor point for the original V shape, absolute value function. But with our shifting rules, we go 2 units to the right. Here's 1, 2, and then we go 4 units up. So 1, 2, 3, 4. You get this particular point, which is 2, 4, and you make your V shape. And that would have been the graph. Oh, my bad. That's one side of it. Here's the other side. So that would have been the graph, the exact, by sketching, the exact graph of y equals the absolute value of x minus 2 plus 4. Any questions?
If it's inside like of the absolute value, is gonna be like it's going to shift to the right or to the left, right?
I did not understand the word you just said. Can you say that again?
Like if it's like the negatives inside the absolute value, so that means the graph is going to shift to the right, right?
That's what I wrote. You
Oh, yeah.
shifting to the right by 2 units.
Okay.
Yep. If it was plus 2, then you would have went 2 units to the left.
Can you hear me now?
I can hear you now.
Okay. So it's like opposite. So plus 2's to the left, negative 2's to the right.
That's correct.
All right.
That's correct. Yep, you definitely got to know your shifting rules. So if it's a plus sign inside of that absolute value, it's to the left. Minus sign is to the right. If the plus 4 is on the outside, like what it is, then you go up 4. But if it was minus 4, you go down 4. Any other questions? All right, let's continue. Problem number 4 states that we want to write the equation of the line perpendicular to the line y equals 3x minus 7 at the point 5, 8. So if 2 lines are perpendicular, what do we know about those lines?
They cross.
They will cross. However, what do we know about the slope? That's right, Yasmin. Yasmin pointed it out in the chat. They're negative reciprocals. So let's say that we have 2 lines. Let's call them L1 and L2. 2 lines, L1 and L2, are perpendicular if M1 is equal to negative 1 over M2. In other words, we call this negative reciprocal of each other. All right, negative reciprocal slopes. All right. So now we go ahead and tackle this problem. What I'll do is the following. You see, I said two lines, L1 and L2. Basically, you're given one of the line, that's usually L1, and you have to find L2. So since L1 is going to be the first line, the given line, y equals 3x minus 7, then you should be able to identify its slope, right? What is the value of M1, the slope of line 1?
3.
Mm-hmm.
It's 3/1.
3 over 1, yeah? 3, which is 3 over 1. I'll write that out. Okay, cool. So we got M1 is equals to 3 over 1. Therefore, M2 have to be the negative reciprocal of this. So if I take the reciprocal of 3 over 1, mainly just flipping this fraction, it's 1 over 3. But what am I missing here?
The y-intercept?
Not a
No, the x. I'm
y-intercept.
sorry, the x.
The
X.
negative?
The
Negative?
negative sign. That's
Oh, yeah,
right. Remember, the definition says negative reciprocal. So if M1 is positive, then M2 is negative. If M1 was negative, then M2 would have been positive. Okay, so keep that in mind. So now that we know what M2 is, right? So now, using M2 is equal to negative 1/3, and the order pair that's giving to us, 5, 8, you can write the equation of the line in point slope form, right? So the point slope form, do anybody know what point slope form is?
Isn't it y minus y1 equals m in parentheses x minus x1?
There you go, you got it. Very good, Chris. So now I'm just going to plug things in accordingly. M2 is negative 1/3, so that's my M. So I'll make that replacement there. X1 is going to be 5, and Y1 is going to be 8. So we're going to get Y minus 8 equals negative 1/3 of, in parentheses, X minus 5. So that would have been the equation in point slope form. Once you have the equation in point slope form, you can then write out the equation in slope intercept form, right? So in addition, in slope intercept form, which by the way is y equals mx plus b, means that in slope intercept form, we can rewrite the equation that we have above by isolating y or solving for y, right? So check this out. We're going to get y minus 8 equals negative 1/3 of x minus 5. So you can distribute the negative 1/3 inside the parentheses. So this will be negative 1 over 3x. And then negative 1/3 times negative 5 is going to be positive, right? Two negatives is a positive. So this is going to be positive 5/3. Okay. Now, one last step here to get y by itself is to add 8 on both sides. So if I do, the 8s would cancel. This will leave me with y equals negative 1/3 x, and then I have to do 5/3 plus 8. All right, so just aside here, if I take 5 over 3 plus 8, what do I need to do first if I want to add the fraction to the whole number?
8 over 1 first, and after
Yeah,
we
over 1. Put it over 1.
Put it
find
over 1.
the denominator.
Now can I add them?
No, you
Yes.
have to find the denominator.
That's right, you have to find the least common
Oh,
denominator.
yeah.
So what is my
Yeah.
least common denominator?
3.
3. So I multiply 3 top
3.
and bottom. So this will be 5/3 plus 8 times 3 is 24 over 3. 5 plus 24 now is 29, so we get 29 over 3. So you get y equals negative 1/3 of x plus 29 over 3. And that would have been your final answer to problem 4. Right, so just writing it out here so it's a little larger. So in slope-intercept form, in point-slope form, we got the y minus 8 equals negative 1/3 of x minus 5. But in slope-intercept form, it's y equals negative 1/3 x plus 29 over 3. Any questions to problem 4?
I have a question for this
Go ahead.
problem. So the formula y negative y1 equal m parentheses x negative x1 is only for the line perpendicular like formula?
No,
or is it-
that's just the point slope form. Point slope
Oh.
form is used whenever you have a point and a slope. It does not necessarily
point
mean
slope.
that you have that you use this only for perpendicular slope. You can use this for any line, really. You can use this form.
Okay, so, and the one in the left side too.
That's
M1
just rewriting the equation in slope-intercept form. So it's basically taking the equation that I have in the blue box
no,
and
I'm saying
rewriting it in
that one.
terms of y.
I'm saying like m1 equal 1 negative 1 over m2, one in the left side on top. So that one is only for perpendicular, or you can use for other.
No, you only use that for perpendicular. I said
Oh,
two
okay.
lines are perpendicular if m1 is equal to negative 1 over m2. If the two lines are parallel, then what does that mean about the slopes?
Are equal kind of.
Yes, the two lines have identical slopes. Yes.
Thank you.
You're welcome. Anybody else? Any questions? No, Yasmin. You can leave it as 29 over 3. All right. Anybody else? Any other questions? All right, let's look at problem number 5. Problem number 5. Yes, whoever asked that question in the direct message, yes. This video will be posted onto YouTube. So, problem number 5 states, draw the graph of y equals 3x squared plus 6x minus 24 and label its minimum. So, first of all, if you look at this equation again, y equals 3x squared plus 6x minus 24, what will be the general shape of this graph? What does it resemble? What would the general shape of this graph look like?
Parabola?
Like a parabola. And the parabola looks like what type of shape?
U shape?
A U shape. Right, so essentially what we're doing here is, based on this equation, it's a quadratic. It looks like, when you deal with a quadratic, it's a parabola, namely its graph, which resembles a U shape. Okay, so the way to go about this parabola, if you want to sketch its graph, is first find its vertex. All right, So the way that I usually use my notation for vertex is as follows. I say that as an ordered pair, the x-coordinate is negative b over 2a, and then I use the notation for the y-coordinate, the output value is f of negative b over 2a. In other words, whenever you find the x value, the x-coordinate of the vertex, you plug it into the function to get the y-coordinate, all right, whatever your equation is. So, to start off, again, x is going to be equal to negative b over 2a. So when you look at your equation, you should be able to determine both the values of a and b. Since b goes on the top, what is the value of b?
6.
B is going to be 6, so we're going to have negative 6 on top. And on the bottom, you have 2 times the value of a. So what is the value of a?
3.
The value of a is 3. So what's 2 times 3?
That's 6.
6. So you're going to get negative 6 on top over 6, which is?
That's 0, right? No.
Negative 1.
Negative 1,
Negative
yeah.
1. Okay, so now when x is equal to negative 1, you can solve for y. So you're going to get y equals 3 times negative 1 squared plus 6 times negative 1 minus 24. So what's negative 1 squared? That's going to be 1. 1 times 3 is 3. 6 times negative 1 is negative 6 minus 24. So what's 3 minus 6 minus 24?
Negative 27.
Negative 27. Okay, so our vertex as an ordered pair is going to be negative 1, negative 27. All right, so let's make a quick sketch. Let's start our sketch, and then we'll fill in the rest of it. Okay, so, sorry. Let's make this a little bit up here. So let's just say that on our y-axis, we scale this by 9s. So here's the origin. I can go up by 9. So I say 9, 18, negative 9, negative 18, negative 27. The vertex is an ordered pair negative 1, negative 27. So from the origin, again, I go 1 unit to the left. Here's negative 1. And I can plot our vertex. So there it is. It's negative 1, negative 27. Now, before I make my parabola, let's just think about it. Is this ordered pair negative 1, negative 27, this vertex, is it going to be a maximum or minimum?
A minimum.
It's the minimum. It's the smallest value. Now, because it's a minimum, then that would imply that the parabola is going to what? Open up or down?
Up.
It's going to open up. And if the parabola is going to open up, right? Imagine if you draw a parabola and it opens up. Then does it cross the x-axis?
Yes.
Yes, it does. If it crosses the x-axis, that means you can find it. That means the zeros are real. So in addition to plotting the minimum, sometimes you also can plot the intercepts, namely the x-intercepts. So if you want to find the x-intercepts, you can set the equation equal to 0 and then solve for x. Right, so in this box, I'm showing you how to find the x-intercepts. So you take the equation 3x squared minus 6x plus 6x minus 24, set it equal to 0, and you solve for x. So if I want to solve for x, I can do this by factoring. For example, What can I factor out of the 3x squared, 6x minus 24?
3.
You can factor out a 3. If I factor out a 3, then what is remaining inside the parentheses? Well, that would be x squared plus 2x minus 8 equals 0. Now, can I factor this any further?
You could have factor like 3x and that would make parentheses x plus 2, right?
No, you cannot. Absolutely not. If you do that, then you lose all points for this problem.
Because it's now
automatically.
multiplying the like plus and like, okay.
Because there's no x next to the negative 24. And yes, so Yasmin has the correct factoring form in the chat. Thank you. You get 3 times x plus 4 times x minus 2 equals 0. So if you solve for x, right? If you solve for x here, all you have to do is set these factors equal to 0. If you set these factors equal to 0, for example, x plus 4 is equal to 0, then x was going to equal to what number? If you take x plus 4, set it equal to 0, then x would equal to what? There you go. Yep,
4.
negative 4. And if you set x minus 2 equal to 0, you get x equals 2. So those are your x-intercepts. So you can plot them, right? So let's say that on my graph, I went from -1, I went 3 units to the left. Let's say here's -2, -3, -4. And let's say from -1, I went 3 units to the right there, 0, 1, 2. I could plot my zeros in red. And now I just got to sketch a parabola. Now I just got to sketch the parabola. So if I sketch the parabola, it looks something like this. It won't be a nice one, because the angle which my arm is located at the moment. Let's see. All right, so it wasn't that bad. I mean, it's bad, but nonetheless, it's still okay. So that would have been your graph. Could have did a little better job at this end, but that's okay. Yeah, same thing. I messed it up even more. So I'll just leave it the way it is. But that would have been it. That would have been your graph, roughly speaking. Any questions?
I have a question.
Okay, sure. I mean,
Where did the x plus 4 and x minus 2 come from?
you have to factor the trinomial x squared plus 2x minus 8. Two numbers that multiply that gives you -8 is 4 and -2, right? 4 times -2 is -8. Yet, when you add them, 4 and -2, the factors, it gives you the +2. It gives you the middle number.
Oh, okay. Thank you.
Mm-hmm. Anybody else? Okay, that's problem 5. Let's continue. Problem number 6 states, draw the graph of y equals the square root of x plus 4. So again, I have to draw this graph using transformation. Well, all I gotta do is just transform this graph based off of what the square root of x looks like. So let's say that on my y-axis on my graph, I first draw the square root function. The square root of x starts at the origin, and it's going to be increasing much slowly than, let's say, a quadratic would increase by. So it's increasing without a doubt, but it's increasing at a slow rate. So here I have the graph of y equals the square root of x. Now I just need to use transformation to sketch this graph. Well, look at the plus 4 here. Is the plus 4 inside or outside of the radical?
Inside.
It's inside.
Inside.
So the plus 4 would mean that we have to shift 4 units in which direction?
Left.
That's right, you shift 4 units to the left. So starting from the origin, I move 4 units to the left. 1, 2, 3, 4. You get -4. That's going to be our new anchor point. And we just make back almost the same graph of the square root function. So I'll do that here in purple. What you're going to get is now y equals the square root of x plus 4. And again, that's the graph shown in purple. Y equals the square root of x is the original graph. That's the graph that we should all know of. And of course, we're just sketching a quick variation of it.
I have a question.
Go ahead.
So if the 4 wasn't in the radical x, it would have been in the left side, like going in the opposite side?
If the 4 wasn't what? Inside of the radical?
Yeah, like it wasn't like radical x plus 4, but it was like radical x plus 4.
Then you had to go 4 units up from the origin.
Oh, 4 units up. Okay. I'm sorry.
Mm-hmm. Right? It's careful to note that that plus 4 was inside of it, because, again, it indicates that we had to go 4 units to the left. This makes sense, by the way, that we have to go 4 units to the left. Let's just quickly justify it. I'll justify it for you, even though you don't need to know the justification. Well, if you're going to calculus, then yeah. If you have the square root of x, right, for example, y equals the square root of x, you can only evaluate this whenever x is greater or equal to 0. Right? Because, again, in a square root function, when you talk about all real numbers, you can't have a negative inside the square root. So the algebraic expression that you have originally inside the inside the square root function, right, the x plus 4, if I were to set that to be greater or equal to 0 as well, I can find all the x values that will satisfy that equation, namely my domain. To do this, I subtract 4 on both sides. And if I subtract 4 on both sides, you get x is greater or equal to -4. So that would have been the domain of that equation, y equals the square root of x plus 4. And that correlates with our graph, because if you look at our graph, at what value of x is the graph beginning at? It begins at -4. -4 is greater or equal to itself. The inequality symbol points us to the right, and that's the direction of the curve. It's going towards the right. So our graph is good. Any other questions? Okay, we'll move on to problem number 7. Problem number 7 states to write the equation of the line given its graph shown below. So if you want to write the equation of the line, just remember the equation of the line is in the form y equals mx plus b. What does the m stand for?
Slope.
M is your slope. And b stands for
The
Y
y.
intercept.
the y-intercept. So if you want to write out the equation of a line given its graph, you got to first compute the slope manually, right? You can either do this from geometrical representation or you just use the formula. right? What is the formula that we use to compute the slope?
It's no run over race or like, oh,
First we find the vertex.
No, there's no vertex here. This is not a parabola question.
You do rise over run.
Rise over run. Rise over run equivalently means the change in y, so you could write it out as y2 minus y1 over x2 minus x1. The y-intercept, on the other hand, this is just an ordered pair where it falls in the form of 0, comma b. Let me ask you this. Based on this graph, can you locate the y-intercept?
Yes.
yes,
Yeah, at what value of y will you have your y-intercept?
15.
Yeah, so as an ordered pair, this is 0, comma 15. Now, in order for me to write out the equation of the line, just find a second point that lies on this line, a second point, compute the slope. You already got your y-intercept, you got the value of b out of the way. Just get the value of m, and then you make some substitutions. So, what's another point I can use here? I could zoom in on the graph. What's another point I could use?
You can use -5, 0.
-5, 0. You can use -5, comma 0. Alrighty, so you can label your 2 points. You can say that this is x1, y1, x2, y2, and compute your slope. Right, so for the value of m, we get 15 minus 0 over x2 minus x1. So that's 0 minus -5. So what's 15 minus 0? That's 15. What's 0 minus -5?
That's 5, right?
That's 5.
Yeah,
So 15 over 5 is equal to
3.
3. All right, so since m is equal to 3, b, your y-intercept, is equal to what value?
The 15.
The
15.
15. Then your equation of your line, the equation of the line is y equals 3x plus 15. And that's it. Any questions?
I have a question.
Go ahead.
So another possible way of solving this problem is by like counting it off the graph, like
That's what I said, the geometrical representation. You could account the rise over run.
okay, I just wanted to make sure that I was correct.
Yeah, you could use that method. No problem. It's just, if you can easily identify your x and y intercepts based on the graph, then why not use it to compute the slope algebraically? Algebraically, it shouldn't be that hard because what is one nice number that the x and y intercept contains? They contain zeros. So it makes computing your slope algebraically, again, not that difficult.
Okay.
Mm-hmm. Anybody else? All right, so problem number 7 was writing the equation of the line given a graph. Now in problem number 8, we're going to be writing the equation of the parabola given its graph. When you're writing out the equation of the parabola, you can do this using the alternate form, right? So the standard form, right, just writing out the difference here. The standard form for parabolas is usually q of x, q standing for quadratic here, q of x equals ax squared plus bx plus c. The alternate form to this is that q of x, or y, is equal to a times x minus h squared plus k, where this time h comma k stands for the vertex. So the first thing that you want to do based off of this graph is locate your vertex. I'm going to zoom in a bit on this graph. Can somebody give me the order pair for the vertex?
1,6.
The vertex is 1, 6. By the way, is this vertex a minimum or a maximum?
Maximum.
It's a
Maximum.
maximum. So this vertex, by the way, just making a note here, this is a maximum. And because it's a maximum, what do I know about the value of a? Is a going to be a positive number, or a is going to be a negative number?
Positive.
Negative.
It has to be negative, right? Whenever a is a negative number, the parabola opens downward. If a is positive, then the parabola opens upward. Okay, so because again, in this graph, your vertex is 1, 6, it's a maximum. That would imply a has to be a negative number. Give me 1 second. All right, so for problem 8 here, all you got to do is plot your vertex inside the alternate form, right? This is going to give us, oh snap, my bad. This is going to give us y equals the value of a, we don't know it yet, but we will soon, times x minus the value of h, which is 1, squared plus k. That will be 6. So we're not done yet. We only got the vertex inside of our alternate form of the quadratic, of our parabola. What I now have to do is find the value of a, plug that in to get the full equation, right? So now, find the value of a. If I want to find the value of a, I have to choose a second point. All right, I have to choose another point, namely I'm choosing any point except the vertex here. So what's another point that I can choose?
3, 0.
All right. Yeah, 3, 0.
Careful,
0, 3.
it's 0, 3. 3,
Oh, yeah.
0 would have been technically down here. But is that point part of the graph?
No, it's not.
No. So the correct way of saying the second point is 0,
0,
3, it's a
3.
y-intercept. Okay, so I could plug that point into my equation. We're going to get 3 is equal to y, right? So 3 now equals the value of a, which we're going to find, times x, which is 0, minus 1 squared plus 6. All right, so let's work this out. What is 0 minus 1?
-1.
Negative 1. What is negative 1 squared?
Positive 1.
Positive 1. So if I take positive 1 and I multiply it by a, then that would be
A.
a. So you get 3 equals a plus 6. How do I get a by itself?
You have
Is-
to subtract to the other side.
Is
What
A
am I
equal
subtracting?
No, no,
Negative
you
or
have to
the
subtract the 6. The 6.
This- There you go. So if I subtract 6 on both sides, the 6 on the right will cancel. What's 3 minus 6?
-3.
Negative 3. So you get negative 3 is equal to a. So if I want to write out my equation now fully in this alternate form, it's going to be y equals the value of a, which is negative 3, times x minus 1 squared plus 6. And that would be my final solution to problem 8. Any questions? Any questions? Alrighty, let's move on to problem number 9. Problem number 9 states write the inverse and specify the domain of g of x equals x minus 6 over 3x minus 1. So the first thing that you want to do is find its inverse, and then you talk about the domain of the inverse. Okay, that's what this problem meant to say. So again, find the inverse. You're finding g inverse of x and its domain. Okay, so if I want to find my inverse here, there's a couple of things that I do which gives you easy points, right? First off, you replace the function notation g of x with what letter?
With y?
Y.
That's right. You replace g of x with y, so this gives you y equals x minus 6 over 3x minus 1. Okay, now, so that should give you 1 point. Another point that you should get for this problem is what? What do I do after this?
You have to like switch y and x places.
That's right. Wherever you have a y, you replace it with an x. Wherever you have an x, replace it with y. So there's only one particular y, so I replace it with an x. So we get x equals x minus 6. Well, now that's going to read as y minus 6 over 3x minus 1 becomes 3y minus 1. So this should give you 2 free points. Now that you have x equals y minus 6 over 3y minus 1, you solve for y. So I'll do it on the other side, so I'm going to just cut this slide in half. So I'm just going to rewrite what I had originally. X equals y minus 6 over 3y minus 1. Okay, how can I get the y by itself? What should I do first?
Cross multiply?
Yeah, you could cross multiply, Miriam. If you cross multiply, you can rewrite x as x over 1. So when you rewrite x as x over 1, this allows us to cross multiply. On one side of the equation, you're going to get x times 3y, which will give us 3xy, and then x times negative 1. So x times negative 1 is negative x. This is now going to equal to 1 times y minus 6. So if I take 1 times y, that's y. 1 times negative 6 is negative 6. All right, good. Now, how can I get y by itself? Well, where are the y's located? Well, they're located on both sides of the equation. I have to make sure that the y's are on one side of the equation. All right, you got to make sure that the y's are on one side of the equation. So therefore, I would subtract y on both sides. This will give me 3xy minus y minus x is equal to negative 6. Now, when the y's are on one side of the equation, the terms that do not have a y must be moved to the other side of the equation. So if I look at the left-hand side, I have all the terms that contain a y, except that there's just one term that doesn't. That one term that doesn't contain a y is this negative x. So I
You
have to
can
move it to the other side as well. So I add x on both sides. When I add x on both sides, this will make the x on the left cancel out. You get 3xy minus y is equal to x minus 6, right? Negative 6 plus x is the same thing as just saying x minus 6. All right, good. We're almost done. If you look at the left-hand side of the equation once again, what do I recognize with both of these terms? Well, they both contain a y. So therefore, I can factor it out. When I factor the y out, we get 3x minus 1 is equal to x minus 6. If I want to get the y now by itself, the one last thing I have to do is subtract 3x minus 1 on both sides. So the 3x minus 1's on the left will cancel. You get y equals, hold on. What did I get back the original equation here? I shouldn't get back the original equation. Give me 1 second. Give me 1 second. Yeah, no, I'm getting back the original as well. No, Mariam, we weren't supposed to move the 3xy. If you move over the 3xy, and then you would have add 6 on the other side, then you're essentially going to get almost the same thing again. Because you could factor a negative out from top and bottom. That's honestly why. Yeah, no, it's all good. So it appears that in this problem, the inverse is going to be, I don't know why this happened. Usually it's not the case, but that's the case here. The inverse is just going to be itself. It shouldn't, though. That wouldn't make sense. Or unless I'm overthinking this. Okay, I think I'm overthinking it. If I find that this is not true, I'll let you guys know. Yeah, I'll let you guys know back on about this one on Wednesday. Yeah, for sure. For sure. So what we have is that our inverse function, g inverse of x, is equal to x minus 6 over 3x minus 1. Okay, so if you want to find our domain of our inverse, you just got to set the denominator equal to 0 to figure out the problematic input there. So if I take my denominator, which was 3x minus 1, and I solve for x, then this becomes 3x is equal to 1. And then you divide 3 on both sides, you'll get x equals 1/3. So your domain of g inverse is going to be negative infinity to 1/3 union 1/3 to infinity. I will definitely get you guys back on this one on Wednesday. I know I have the right setup, but my answer is why. Why did this happen? So I'm curious. I got to figure that out. So I guess later on tonight, that's what I'm going to do. All right. Any questions? Okay, let me continue. So we're up to problem number 10, and it says that we want to simplify by using polynomial long division. So if I want to simplify this by using polynomials long division, just remember you have your dividend and your divisor. The dividend is what goes on inside of the long division bar. Your divisor is x minus 2. So what we have is the following. I do it on the side here. We have x minus 2, and then again, that's outside of the division bar. Inside of it, you have x to the third plus 4x squared minus 2x plus 8. So I'm going to do the scrap work on the side. I'll call this scrap. And here's how this works. First of all, you want to ask yourself, how many times can the first term of your divisor go into the first term of your dividend? In other words, if I simplify x cubed over x, if I can, if I could simplify this, what would it be? That would tell us how many times can x go into x cubed. So x cubed over x, can we simplify it? Yes or no?
Yes.
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 X cubed over x is going to be what?
X squared.
X squared. That's right. So the x squared now is going to be the number of times that x can go into x cubed. So I write it above the 4x squared. I kind of keep my powers, my degrees aligned up. All right, so now I do some math. I'll do this on the side. I say, okay, I'm going to take this x squared term and I'm going to multiply it by x minus 2. Well, if I take x squared times x minus 2, that's x to the third minus 2x squared. And that I can write inside, underneath the first two terms of the dividend. So it's x squared minus 2x squared. All right, and of course I have to subtract. So what is x cubed minus x cubed?
That's 0.
Say it again.
0.
0, it cancels out. Now, what's 4x squared minus negative 2x squared?
That's 2x squared, yeah.
Careful. You have 4x squared minus negative 2x squared.
Oh, okay, 6 and then.
That's going to be 6, right? So be careful.
Yeah.
Those two negatives become a positive. So this is really 4x squared plus 2x squared, which is 6x squared. All right, I bring down the next term, which is the negative 2x. So we have to do this again. We want to ask ourselves, how many times can x go into 6x squared? So how many times can x go into 6x squared?
6x.
6x. That's right, you get 6x. So we write the 6x above. So we say plus 6x. And now we take 6x and multiply it by the divisor, x minus 2. So 6x times x minus 2 should be 6x squared minus 12x. So I'll write that underneath, 6x squared minus 12x. Okay, and of course I subtract again. So what happens when I take 6x squared minus 6x squared?
Is 10x, and I mean is like
No,
0.
well, what
and
happens when I take 6x squared minus 6x squared? Let's
Zero.
go. That's
Zero.
0. That goes away. Now we have negative 2x minus 12x, right? Negative
Is
2x
10x.
10x.
minus 12x. That's the same thing as saying negative 2x plus 12x, which is 10x. All right, so now you got 10x and you bring down the 8. So how many times can x go into 10x?
10.
10, right? So I'll write the plus 10 here, right? 10x over x is just 10. So now I take 10 and multiply it by the divisor, x minus 2. So what's 10 times x? Well, that got to give us back 10x. 10 times negative 2 is negative 20. So we get 10x minus 20. And we work this out. What's 10x minus 10x?
Zip, it cancels.
That cancels. And now what we have is 8 minus negative 20. So what's 8 minus negative 20?
Negative 12.
Careful.
28,
20.
28.
28, because
Oh,
this is
right,
8
right.
plus 20, which is 28. Okay, can x go into 28 now?
No.
So our solution should be the quotient x squared plus 6x plus 10 plus 28 over x minus 2. You usually write it out, your solution as quotient plus the remainder r over divisor. Right, so the remainder here was the 28.
Wait, we have to write plus 28 over x negative 2? Because I've never did that like in my class.
Say it again.
At the solution, we have to write at the bottom like 28 over x negative 2 too.
28 over x minus 2, yes. Usually you write it out as quotient plus remainder over divisor. Sometimes the professor just say write quotient plus remainder 28, right? They'll say something like write r 28, but it's okay to say 28 over x minus 2.
Or can I let it just like x squared plus 6x plus 10, that's it? Or
No, no, that's not it. If you put that, then your answer is wrong.
okay.
Your answer is wrong.
I have a question too.
Sure.
So what if I just write x squared plus 6x plus 10 remainder 28? Is it correct or?
That's okay. I could pick up on that. But usually the format is quotient plus remainder over divisor.
Okay.
Yep.
In the exam, should I write everything that you just wrote or
You
like
should.
the solution?
You should.
Because if I don't, like, it ain't gonna count at all, even if I get the answer right.
Well, I mean, if you don't show your work and you made some mistake, then there's no way that your professor can go back and justify and give you partial credit. So that's why it's important. Your instructor will always stress show your work on the exam, because partial credit will be given. At least if you could find, if you were to make a mistake, we can find it. And we could reward you with some partial credit. Anything else? Any other questions? Okay, let's continue. Let's do problem number 11. Problem 11 states to solve for x. You have 4e raised to the power of 3x plus 7 equals 128. So the idea here is that when you want to solve for x, you have to get x essentially by itself. And if you notice, it's currently located in the exponent. All right, so how can I solve for x in this equation? What should I do first? That's right, Eve. You would divide by 4 on both sides. So if I divide 4 on both sides, the 4's on the left would cancel. You'll get e to the power of 3x plus 7 is equal to 128 over 4. So I think 128 over 4 is 32. That's right. Thank you. All right, so we have e to the power of 3x plus 7 is equal to 32. Now, how can I get x by itself here? What should I do to both sides of this equation? You can't necessarily move the e, because if you notice, it's e raised to a power. E is the base. E raised to the power of 3x plus 7. So I just can't move e. Oh, like make it ln. Yes, you can use the natural logarithm. Now, just remember, if I apply a natural logarithm on one side of the equation, I apply the natural logarithm on the other side. So I have to take the ln of both sides of the equation. So this will give me ln of e raised to the power of 3x plus 7 is equal to 32. So again, if I apply the ln on both sides, then this is just ln of e to the 3x plus 7 equals ln of 32. Now, there's an important property about ln's. You see, if I have the ln, so this is a property of natural logarithms, or logarithms in general. If I have ln of some base b raised to a power n, I can always move n in front of the ln. That's what the power rule states. So the power rule allows me to take n, whatever my exponent is, and stick it in front of the ln. Okay? So just rewriting that equation using this power rule for ln's, we have 3x plus 7 should go technically in the front of the ln of e equals ln of 32. All right. Now there's another important rule. Do anybody know what ln of e is going to be?
1.
It's always equal to 1. So this value is going to be equal to 1. When I multiply by 3x plus 7, you will still get back your 3x plus 7 is equal now to ln of 32. Okay, so how can I get x by itself now? What else should I do?
Divided by 3 on both sides.
Careful, there's something else I have to do first, which was
Oh,
mentioned in the chat.
subtract 7.
Subtract 7 first, and then we can divide by 3. So we're going to get 3x, 7's are gone, is equal to the ln of 32 minus 7, and then we can divide by 3 on both sides. Oops. So if I divide by 3 here, you're going to get x is equal to ln of 32 minus 7, all divided by 3. And that's your solution. All right, so again, what really helped me solve this equation was knowing that I could have used the power rule for ln. It's the same thing as the power rule for logs. And then also knowing our identity. That if I take the ln of e, that is always going to equal to 1. All right, any questions here with problem 11? All right, I'm going to continue. We're going to look at problem number 12. So problem number 12 states to compute and simplify the difference quotient. Do anybody remember what's the difference quotient?
Is it f of x plus h minus f of x over h.
That's right. It's f of x plus h minus f of x all divided by an h. So if I need to compute the difference quotient here, what I'm going to do is first compute f of x plus h, and then make some substitutions into my difference quotient, right? So first, compute f of x plus h. So if I want to compute f of x plus h, that means when I look at the original function, wherever I see an x, I replace it with x plus h. So how many times, how many times does the variable x appear in the original function?
Once.
Once, that's right, just once. So I'm going to replace that x by x plus h. So we get 3 times x plus h squared plus 7. Now, x plus h, when you square it, is the same thing as saying x plus h times x plus h plus 7. So this allows me to FOIL. If I FOIL this, we take x times x, which is x squared, x times h, which is xh, h times x is the same thing as xh, and then h times h is h squared. Now, if I look inside of the parentheses, can I combine any like terms?
Yes.
Mm-hmm.
X plus h. I mean xh.
That's right.
plus
How many xh's do we have, Mariam?
2.
2. So we get 3 times x squared plus 2xh plus h squared plus 7. All right, so the last thing that you want to do here is just distribute the 3 inside the parentheses. So this will give me 3x squared plus 6xh plus 3h squared plus 7. All right, so now that this is my f of x plus h piece, I can plug it into our difference quotient. So in the numerator, I like to keep f of x plus h separated from f of x. So this will be 3x squared plus 6xh plus 3h squared plus 7 minus the original function, which is 3x squared plus 7, all divided by an h. So when I keep them separated with using these brackets, because of the minus sign in between the two brackets, whatever terms they have in common, I can get rid of. So what terms can I eliminate?
3x squared and plus 7.
That's right. Get rid of the 3x squares, get rid of the 7s. This will give us 6xh plus 3h squared, all divided by h. All right, so if you look at your numerator, the only terms that should be remaining are terms that involve an h. This allows me to factor it, okay? I can factor the h out. So if I do, this will be 6x plus 3h inside the parentheses, all divided by an h. Now, as long as h is not equal to 0, what happens to the h that I factor out with the h on the bottom?
We
A
cancel.
simplified.
Cancel.
They cancel out, and whatever you have inside the parentheses now will be your final answer. So that would be 6x plus 3h. And that is a solution to problem 12. Any questions? So we have problem number 13. I think honestly this might be the longest problem on the exam. Honestly, it's drawing this graph. We want to draw the graph of f of x equals x minus 3 over x squared minus 49. When you're drawing this graph, you usually do it in a 6-step approach. So the first thing that you want to do before I mention the 6-step approach is see if anything can be factored, right? For example, look at your numerator. Your numerator is x minus 3, so I can't factor the numerator. But if you look at your denominator, it's x squared minus 49. Can I factor my denominator? Yes or no?
X minus 7, x plus 7.
There you go, Yasmin. It's a difference of 2 perfect squares. You have x plus 7 and x minus 7. So let me ask you this question. Did any of our factors can be canceled out here?
No.
No. Because there's no factors that can be canceled out, then your graph will not contain any holes. Okay, so just note, no factors were canceled out. So the graph contains no holes. It's going to contain breaks, but no holes. All right, now we can proceed to the 6 steps that I use to draw our graph. So step number 1 is usually just finding the y-intercept. Find the y-intercept. And if you want to find the y-intercept, well, how do I find a y-intercept for any graph? What do I set equal? How do I find the the y-intercept algebraically?
X is equal to 0.
Set x equal to 0. So if I set x equal to 0 here, then in my function, f of x, I'm computing f of 0. So this will be 0 minus 3 on top. And on the bottom, you don't have to use the factor form here. You could just use the original form. You have 0 squared minus 49. So 0 minus 3 is negative 3. 0 squared minus 49 is negative 49. So if you look at this fraction, negative 3 over negative 49, you can simplify it by just getting rid of the negatives. This is 3 over 49. So as an order pair, your y-intercept is 0, 3 over 49. That's step 1. By the way, if you look at this y-intercept, 3 over 49, what number is it going to be close to? What whole number, or what number will this fraction be close to? For example, will it be close to 1? Will it be close to negative 1, 0?
0 and 1. 0 and 1, right?
Yeah, it's gonna be
Zero?
between 0 and 1, but a little bit more closer to 0.
Yeah.
All right,
Yes.
so that's our first step. All right, good. Step number 2 is where we find, well, if I find a y-intercept, well, what else I have to find?
X-intercept.
Find an x-intercept. Sometimes the graph might not have an x-intercept. Like, for example, if it's just a constant term in the numerator, then it won't have an x-intercept. But if you want to find this x-intercept, you set the numerator equal to 0. The numerator was x minus 3. So if I set x minus 3 is equal to 0, then x is going to equal to what value?
3.
Is going to equal to 3. So this here, as an order pair, is going to be 3, 0. That's our x-intercept. The graph will cross or touch the x-axis at 3, 0. All right, so we got the first 2 steps done. Steps 3 and 4 is where I find my asymptotes. So I first find the vertical asymptote. How do I find the vertical asymptote? What do I do algebraically?
You do 1 y over y negative y1. That one, right?
Nope.
You first factor the denominator.
That's right.
And then you just equal each to 0, and then you just
Solve
get
for
your
x.
answer, I
There
guess.
you go. That's right. You got it. So you see the denominator was originally x squared minus 49. So you set it equal to 0, and you're going to solve for x, right? So you set the denominator equal to 0. But our denominator in factor form was x plus 7 times x minus 7. So when I set this equal to 0 and split this to two equations, we get x plus 7 equals 0, and we get the equation x minus 7 is equal to 0. In the first equation, if you solve for x must be equal to negative 7, and in the second equation, x is equal to positive 7. So this is a vertical asymptote. That means the graph will never touch the curve. The curves will never touch the vertical asymptotes. It gets really close, but it doesn't touch them. All right, so we have step 3 done. Now we just got to do step 4. Well, after you find the vertical asymptote, you find the horizontal asymptote. The way that you find the horizontal asymptote is that you compare the degrees of the numerator versus the denominator. Okay? Compare degrees of n, the numerator, to the denominator. So what is the degree of the numerator? What is the highest power among the x minus 3?
In the numerator,
Yes.
1.
1. What about the denominator now? When you look at x squared minus 49.
2.
2.
2. So what statement could I make regarding n versus d? Is n less than d? Is it equal to d? Or is it greater to d?
N is
And it's
less.
less.
That's right. N is less than d. So because n is less than d, what do I know about my horizontal asymptote? Well, the horizontal asymptote is going to be the line y equals what?
0.
Y equals 0. So we did steps 1 through 4, right? Step 1, y-intercept. Step 2, x-intercept. Step 3 is the horizontal
I got a
asymptote.
question.
Step 4 is the horizontal asymptote. What's your question?
So what if the denominator is less than the numerator?
If it's n greater than d, then there's no horizontal asymptote. Horizontal asymptote is a way of describing end behavior. End behavior. And you saw end behavior with polynomials. If there's no horizontal asymptote, then essentially the graph, either from the left or from the right, is going to increase or decrease without bound, meaning that it goes either to negative infinity or positive infinity. There's no horizontal asymptote if that's the case. If n is equal to d, then we take the ratio of their leading coefficients of the highest powers. That is something that we'll look at on Wednesday, when I do an example of that on Wednesday. But keep in mind that if the degrees are equal, then you take the ratio of their leading coefficients. All right? But more importantly, for this problem, since we got the first 4 steps done, steps 1 through 4, step number 5 states to plot what you have, find some test points, and step 6 is where you complete the graph. Okay, so step 5 is where we plot steps 1 through 4. And find some test points. Find test points, then complete the graph. All right, so check this out. What I'll do is I'll do the graph on this side, on the right. Let's say that's my y-axis. And of course, here's my x-axis. So we got to plot our y-intercept. So our y-intercept is 0, 3/49. That point is close to the origin, right? So if this is my origin here, let's say if this is 1, then our y-intercept should be really close to 0. So that would be the point shown in blue. Next, we plot our x-intercept, which is 3, 0. So from the origin, I just got to move 3 units to the right. So let's say here's 1, here's 2, here's 3. So this would have been another point on this graph, 3, 0. All right, so we got 2 points so far. Now we plot the vertical asymptotes, which were -7 and 7. So -7 would have been, let's say, 1, 2, 3, 4, 5, 6, 7. So that would have been this dashed line here as the vertical line, the vertical asymptote. X equals -7. Now I do +7. So I go 1, 2, 3, 4. That would be somewhere here. So again, this line is going to be x equals 7. So x equals -7, x equals 7 are my vertical asymptotes. Now I plot the horizontal asymptote. So the horizontal asymptote is going to be the line y equals 0. If I want to plot y equals 0, then that's specifically replotting or drawing a line directly on top the x-axis, which is shown here in purple. Okay, so in purple, I have the line y equals 0. That's my horizontal asymptote. All right, so I need some more test points here. What I'll do is I'll extend this graph just a bit. Might need another test value there. Okay, so we already got 2 points, like I mentioned. Oops, sorry. We got a y-intercept, we got an x-intercept. But I need some more points. What I need to choose is points to the left and to the right of each asymptote. So for example, if x is equal to -7, one of our vertical asymptotes, I need to choose a value to its left and a value to its right. Can I get a value to its left and to the right of our graph? Namely left and right of this vertical asymptote? Anyone? Vertical asymptote is x equals -7. Can I get an x value to its left and to its right?
Yeah, you could use the 8,
You can
negative 8 or positive 8.
You could use -8. That's one. What's another value I could use?
Positive 8.
Well, I need one that's directly to the right of the vertical asymptote. So I'll use I can't use 8 yet because that would have been for the other vertical asymptote. I need
Oh,
some-
anything above negative. I mean, below
yeah,
negative
anything
8.
basically between -7 and 0.
-6, 7,
Thank you. You can use
Neg-
-6.
6, yeah.
What I'll do is I'll use -5. I think it'll be easier to compute. So I have -8, -5. So what I can do is I can use the same numbers for x equals 7. Instead, they're going to be positive. So you have 5. Our axis, I just have to extend it a bit. So let's say I use 8. Okay. All I really need now is just to know what the sign of these values are, right? So for example, if I compute f of -8, this will be equal to -8 minus 3 over -8 squared minus 49. I mean, you could define the signs, but you can actually compute the values too if you like. For example, what's -8 minus 3?
It's not like negative.
-11, that's right. And if you look at your denominator, it's -8 squared. So what's -8 squared?
64.
64? 64 minus 49 is? 64 minus 49. $15. There you go, Yasmin. You get 15. So -11 over 15, this is a value that's less than -1. So let's say if this was -1 here, then the order pair -8, -11 over 15 will be located somewhere here. It's in between 0 and -1. It should be a little bit closer to -1. So somewhere around there. Okay, now let's see what happens when I plugged in -5. Well, this is going to equal to -5 minus 3 over -5 squared minus 49. So what is -5 minus 3?
It's -8.
-8.
Yeah.
Over, well, what's -20? -5 squared is 25. So what's 25 minus 49? -24. And you can reduce this. -8 over -24 is positive 1/3. So that order pair, -5 1/3 is still going to be below this positive 1. Let's say somewhere around here. So that's a second point I have, a test point. Now I need 2 more test points. I need to know what f of 5 is, and I need to know what f of 8 is going to be. Well, f of 5 is 5 minus 3 over 5 squared minus 49. So what's 5 minus 3?
2.
2. 5 squared is 25, so 25 minus 49 is still -24. So 2 over -24 is -1 over 12. So -1/12 should be between 0 and -1, but a little bit closer to 0. So it should be where I had that number 5 written. Just going to erase it real quick. Where I had the number 5 written would now be -1/12. All right, so I just need one more test point, f of 8. Well, that's 8 minus 3 over 8 squared minus 49. So what's 8 minus 3?
Five.
5. 8 squared minus 49, we did that earlier when we did -8 squared minus 49. That's 15.
1/3.
So this will reduce to 1/3. Very good. So we'll get another point somewhere here. All right, so we plotted steps 1 through 4. We found our test points. Now we got to complete the graph. Let's complete the left end and the right end of the graph first. You see, since your graph, my bad. Since this order pair that we had for -8, that was -8, comma, -11/15, is trapped between the two asymptotes, then as you're getting closer and closer to the vertical asymptote, it should be decreasing without bound. Why? Because as you look at you're approaching -infinity, essentially, as you're approaching -infinity, it gets closer and closer to the line y equals 0. So in other words, if I were to extend this graph, out just a little bit more on this end, it's not going to be touching the horizontal asymptote, but instead it gets really close. So it should look something like this. All right. Now, on the opposite end, you have the order pair 8, 1/3. That means that, again, if I were to stretch that out, I can't now. It's too late. But as you're approaching x equals 7 from the right, it has to increase without bound. So it gets really close to the vertical asymptote. And as you're approaching 8, as you're approaching infinity, the graph should be getting closer and closer to y equals 0, because that's what the horizontal asymptote does. It tells you that, okay, from the far left and from the far right, from the far left versus the far right, you're getting closer and closer to that horizontal asymptote. That's end behavior. Now that I got the end behavior out of the way, I just got to focus on this middle piece. So look at your ordered pairs. We have -5, 1/3. Then 0, 3/49. That was a y-intercept. We have the x-intercept is 0. And then lastly, -1/12. Right? So 1/3, 3/49, 0, and -1/12. If you look at these ordered pairs, are they increasing or decreasing?
Decreasing.
They're decreasing. So that means that if it's decreasing, then as you're approaching -7 from the right, the graph should start all the way up, decreases, and as you're getting closer and closer to the second vertical asymptote, x equals 7, it should continue to decrease. So it looks something like this. So you're getting closer and closer to x equals -7 from the right. It's decreasing. And it keeps that trend going, right? So as you're getting closer and closer now to x equals 7, it's decreasing without bound. And that's your graph. It's not a pretty one. I could show you a pretty one on GeoGebra if you want, but I mean, if you plot this on GeoGebra, draw this graph, you'll see that it resembles the one that I have. Of course, mine was not that nice looking, but it worked. We solved the problem.
I have a question.
Well, go ahead.
Why would pick -8 and in the other side 8? Why would you like pick
You
like
could
a
pick any
9 or
numbers
like
you want.
-9?
Listen, you pick any numbers you
Like
want. Listen,
any
listen.
number.
Let me speak. Don't speak over me. It's kind of rude. You could pick any number that you
Sorry.
want as long as it's left and to the right of each vertical asymptote. So I chose -8 and -5 because that's directly to the left and to the right of our vertical asymptote of -7. But you could have chose -10 and -6, and you could get something very similar to what I have. Your graph will, no matter what test point you use, your graph should resemble or mimic mine's. Any other questions? Any other questions? We're good on this? I told you this is the one problem that I think is the most taxing of them all. We're gonna look at another example of this next time. But you should practice other examples that your instructor gave you. Look at the other type of functions your instructor give you. And then try to use the same steps that I have, right? My step 5 is technically steps 5 and 6. So I did both steps in one. Okay, let's move on. We only got 3 more to do, and that would wrap up today's review. So we got problem 14, states to draw the graph of the following piecewise function. This graph is a little bit more easier to draw, except I made a typo. The typo here is that it should have been x is just greater or equal to 1 in the second equation. Originally, it was x greater or equal to 10. That didn't make sense. It had to been greater or equal to 1. All right, so if I want to draw this graph, what I need to do is first figure out the value of x where my domain changes at. Right, so your domain or your rule changes at what value of x? If you look at your function, you have f of x equals 10 minus 5x, provided that x is less than 1, and you have 5x minus 10, provided that x is greater or equal to 1. So, your domain changes at what value of x? Has anyone seen this type of question in their class? At what value of x is the domain changing at?
1.
There you go, Miriam. Thank you. Domain changes at x equals 1. So because the domain changes at x equals 1, that means that when you want to graph an equation, namely a piecewise function that involves multiple equations, at x equals 1, you're going to have an open point versus a closed point. So now what I need to do is plug in the value x equals 1 into both equations. One of the solution is going to be an open point and the other one's going to be a closed point, right? So when x is equal to 1, you're going to have the following. For equation 1, it's going to be 10 minus 5 times 1. Well, 5 times 1 is 5, so 10 minus 5 is equal to 5. This gives me the order pair 1, 5. Now for equation 2, you have 5 times 1 minus 10, which is negative 5. So as an order pair, it's 1, negative 5. So which one of these 2 points, which one of them is the open point and which one is the closed point? I'll give you a hint. Look at the inequality symbols. If it states x is less than 1, then that
Second one
order
is
pair 1, 5, is it going to be open or close? Yeah, that's right. So we have open point at 1, 5, and at 1, negative 5, because the inequality includes the equal sign there, x is greater or equal to 1, then 1, negative 5 is a closed point. All right, so you plot those 2 points. So let's say here's 0, let's say here's 1. I'm going to scale my y-axis by 5s. So let's say here's 5, here's 10, here's 15, here's negative 5, here's negative 10, here's negative 15. All right, so at 1, 5, it's an open point. At 1, negative 5, it's a closed point. All right, so now I have to plot the graph of both equations. Well, look at equation 1 again. Equation 1, I'll write it on the bottom here. Equation 1 was y equals 10 minus 5x. If you look at that equation, what type of equation is 10 minus 5x?
Slope intercept.
Yeah, it's a linear equation. You could identify your slope and your intercept. So because it's linear, what is my slope, Mariam?
Negative 5.
That's right. And my y-intercept is?
10.
10. So because the slope is negative 5, what do I know about equation 1? Is it going to be a line that's increasing or decreasing?
Decreasing.
It's decreasing. And will our graph include the order pair 0, 10, our y-intercept?
No.
Yes, it will. Because if you look at the first equation, it's only true if x is less than 1. So I can plot my my intercept, my y-intercept, and I can draw a line that's decreasing. Right? So from left to right, it's a line. Left to right, it's a line that's decreasing. This first equation is y equals 10 minus 5x when x is less than 1. All right, let's look at equation 2. Equation 2 is y equals 5x minus 10. So what do I know about the value of the slope? Since this is also a linear equation, what's the value of my slope?
5.
5. So is the line going to increase or decrease?
It's gonna increase.
It's going to increase. So at the order pair 1, -5, all I got to do is just draw a line that's increasing. So for the second line that I just drew, that's going to be y equals 5x minus 10 for when x is greater or equal to 1. And that's it. That's your equation. Just note that I didn't need to plot my y-intercept here. Even though my y-intercept is -10 for equation 2, note that you don't need to plot it, because if you look at your domain for equation 2, where does it begin at? At what value of x? It begins at 1, that's right. If I want to plot the y-intercept, then I would have technically had to plot at least begin at x equals 0, which is not the case here for equation 2. So therefore, this is your graph. Any
I
questions?
have a question.
Sure, Mariam.
Okay, so how did you know that this is an open point and this is a closed point? Is it because of the negative that was over there, or?
No, it's because of the inequality symbols, right? This symbol means less than. This one means greater than or equal to. So long story short, because it says less than 1, then I know that I cannot technically include 1 into the first equation. Hence why it's an open point. It's not part of the graph. It's just an indication that, okay, somewhere around 1, 5 is where the first equation is going to end, and the second equation will begin at 1, -5, because again, 1 is included in the second equation.
Oh, okay.
Does that make sense?
Yes.
That's why I said the first thing that you should recognize is where your domain/rule, locate where it changes at. It changes at x equals 1. So the open point indicates where it stops, the first equation, at least for this problem, the first equation stops at equation at this point 1, 5, hence it's open, and then it's closed in the second point, in the second equation, because we're including 1 into the second equation. Questions?
Yeah, I have a question. For the equation 2, why the y-intercept is not -10?
It is
Like-
-10. But,
Yeah,
but why am I not plotting it? I answer that. We're not plotting it because look at the second equation. Its domain is when x is greater or equal to 1. If I want to plot a y-intercept for that equation, then I have to include x equals 0 in that domain. But is 0 greater or equal to 1?
yes.
No, 0 is not greater or equal to 1, so therefore I cannot plot a y-intercept there. And that's the reason. Any other questions? Okay. We have 2 more questions to go, and that would be it for today. So problem 15 states, use f of x equals log base 5 of 2x minus 1 to address the following questions. So for part A, if I want to find my domain of f, then what must be true about this logarithm? How do I algebraically find the domain of log base 5 of 2x minus 1? Any suggestions? What should I do?
We substitute something with 0.
There's something going to be involved with 0. That's right. What would be the something that you think I'll have to substitute?
2x negative 1 equals 0.
2x minus 1, that's right. So you have 2x minus 1, and then we have a 0. So what should go between the 2x minus 1 and the 0? Should I have an equal, greater than, less than? What should go in this middle? Is it going to be an equality, an equation, or an inequality?
An equal sign.
It's a greater than sign. It has to be greater than. So 2x minus 1 is greater than 0. And you solve for x. So if you solve for x, you add 1 to both sides. You get 2x is greater than 1. And then you would divide by 2. So you get x is greater than 1/2. So because it says that x is greater than 1/2, in interval notation, is going to be open parentheses, 1/2, comma, infinity. And that's your domain. Now that you have your domain, you compute f of 1, okay? So 1 is definitely going to be part of our domain. You could plug that value into x, right? So in other words, if I want to compute this, I would do, right, if I want to compute f of 1, then this is the same thing as saying log base 5 of 2 times 1 minus 1 is going to equal to some value. That value, I'm just going to call it, I'm going to call it A for right now. Okay, I'll call it A for now. Okay, so what's 2 times 1 minus 1?
1.
1. So you get log base 5 of 1 is equal to A. Now, if you want to solve this equation, this logarithmic equation, you can convert logs into exponential form. If I convert this into exponential form, my base is going to be 5. My exponent is actually A, right? Logarithms is an exponent. So you can say 5 raised to the power of A is equal to 1. Now let's think about it. If you have a base raised to some power, and you're getting back that the answer is 1, and of course your base is not 1, your base here is 5, then what does that tell you about the value of A? A must be equal to what number? There you go. You guys got it. A must be equal to 0. So that would have been the solution to part B, right? You plug in the value of 1 for x, simplify the logarithm just a tad bit, you'll get log base 5 of 1, set it equal to A, so that way you can convert it into an exponential. You get 5 to the A power is equal to 1. And now you just got to think about the situation. Well, A has to equal to 0. Let's look at part C as a follow-up to this. Part C now is going backwards. It says that find the number A such that f of A is equal to 2. Right? In other words, when I plug in A into my function, this will give us log base 5 of 2A minus 1 must be equal to 2. Right? So in other words, log base 5 of 2A minus 1 is equal to 2. If you want to solve for A here, rewrite the logarithm as an exponential expression. So what would be the exponential expression here? First, start with your base. What would be my base? 5. That's right. Base is 5. What is the exponent?
Two.
2. So you get 5 squared is equal to 2a minus 1. This is an equation that we can solve, because what is 5 squared?
25.
25. Well, 25 is equal to 2a minus 1. So if I add 1 on both sides and then divide by 2,
It's 12.
you're going to get a is equal to, careful, not 12. Remember, you have to add 1 to both sides. So 25 plus 1 is?
Oh, 26.
26.
13. 13.
Then when you divide it by 2, you get 13. So that would be the solution for a. A is equal to 13. And you can do a quick check of this, right? If you do a quick check, this means that log base 5 of 2 times 13 minus 1, is it equal to 2? Well, let's see. What's 2 times 23 again? 2 times 13, that's 26. 26 minus 1 is 25. So this gives us log base 5 of 25 is equal to 2. But if I rewrite this in exponential form, it's just 5 squared is equal to 25. Is that a true statement? Yes, it is. So it works out. Any questions to problem 15? Towards the ending of your homework, if you're using MyLab, Pearson MyLab, you should be using it. There's going to be problems related to converting logarithms to exponentials. You should practice those because it will really help you with solving parts B and C of problem 15. For part A, whatever's inside the parentheses, whatever comes after the base, you set that expression greater to 0. Any questions?
No.
All right. Let's look at problem 16. Problem number 16 states, if 40 people contribute to a performance space, then each pays $100. For every dollar less that people pay, 4 additional people contribute. Use an equation to determine the maximum amount of money that can be raised. So, to do problem number 16, the way that I teach this to my students when I teach pre-calc is we use this acronym PQR. Some of you who are probably in Raphael's class probably saw this acronym because I used it during our second review. If you guys can recall, what does the P stand for? What does the P represent?
Price,
Price, there you go. What does Q stand for?
quantity,
Quantity. And R stands for?
revenue.
Revenue. So what we're going to have to do here is we're going to have to write a price function, P of X, a quantity function, Q of X, and write a revenue function, R of X. You see, the revenue function, the reason why this acronym PQR works is because R is always equal to P times Q. Okay? The revenue function, R of X, is found by multiplying the price function by the quantity function, Q of X. So the way that I set this up is first find the price function, the quantity function, and then we're going to multiply them together to get the quantity, the the revenue function. So I write the price and quantity simultaneously. So for our price function, it says that, okay, if you read that first sentence, it gives you your initial values. It says if 40 people contribute to a performance space, then each pays 100. So what is my initial price? If you read
100.
the $100, that's right. The initial price is the 100. So my price function begins with the number 100. On the other hand, what is the initial quantity? What are we? How many people are we beginning with? 40. That's right. So the price function starts with 100. The quantity starts with 40. Now, if that was just the only two numbers I dealt with in this problem, then the revenue would have just been 100 times 40. But that's not the case here. Because it states for every $1 less, for every $1 less that people pay, 4 additional people joins or 4 additional people contribute to the performance space. Okay, so how can I express every $1 less mathematically? What does that mean, every $1 less? How can I write that out mathematically? Well, first, think about what operation is used to express less, right?
Subtraction.
Subtraction, that's right. So our price will start with 100, and we're going to subtract by some value or some expression. So what would the expression be? Do I just write $1? Do I write something else? What should I write? 100 minus what?
1x.
1x, that's right. 100 minus 1x, which by the way is just the same thing as saying 100 minus x, right? Where x is the number of times, I'll write that in a moment, where x is the number of times, or x is for every dollar less that the people pay. Okay, now because there's this correlation, this relationship, every time that there's $1 less that people are paying, how many more additional people joins?
4 additional.
4 additional. So additional means that I have to add. I'm going to be adding by 4. But is it just going to be 4, or is it going to be 4? X. There you go. Right? There's that that's the correlation in that second sentence between the price and quantity. For every dollar less that people pay, 4 more people contribute. So for example, let's say that the people paid $3 less. If the people paid $3 less, then how many people contribute?
3x.
3. Well, no. Well, no. I'm saying for if let's say that it was exactly 3. That I knew that 3. Sorry, my bad. Let's say that it decreased by $3, right? For every dollar, let's say this time it was just decreasing by $3. If I was decreasing it by $3, then how many more people contribute? Well, it would have had to been 4 times 3. Okay, there's basically this 1-to-4 ratio. All right, so now that I have my price and quantity function, you construct the revenue function. So the revenue is 100 minus x times 40 plus 4x. Now, you expand this through foiling, right? You take 100 times 40, that will give you 4,000. 100 times 4x is 400x. Negative x times 40 is minus 40x. And negative x times 4x squared is minus 4x squared. Okay, so I simplified this just a tad bit. The 400x minus 40x is 360x. So this is 4,000 plus 360x minus 4x squared. So you could rewrite the revenue function where the powers are descending. So you could say minus 4x squared plus 360x plus 4,000. Now this problem makes sense that I'm finding a maximum here, right? Because what type of function is this revenue function?
Quadratic?
It's a quadratic. And how do I know it's a maximum? Well, what's the value of a in this quadratic function?
-4.
-4, and therefore the parabola of this quadratic should be opening down. So where would the maximum be located? If I deal with a parabola that's opening down, then the maximum is located where? At what point? The highest point. And how do you find that highest point? What's another way of expressing that highest point? Right? Look, a was equal to -4. So that implies that the parabola is opening downward. So the max is at the highest point, which is the vertex. There you go. So if I want to solve this problem, determining the max amount of money that can be raised is equivalent to finding the maximum, finding the vertex. So we'll say that, okay, x is equal to -b over 2a, and then I can plug it into our function. So -b would be -360 over 2 times -4. So if I do the math, 2 times -4 is -8. So this is -360 over -8. 360 divided by -8, I think that would be like 45. Yeah, that would be 45. So when x is equal to 45, meaning that essentially if this person lowers the price 45 times, then we could find the max revenue. So the max revenue, the way to compute it, R of 45, I wouldn't necessarily plug it into this revenue function because it looks a little bit harder to compute. Instead, I would plug it into the price and quantity function, right? So if I want to compute R of 45, it's the same thing as computing the figuring out what's the price when x is 45 multiplied by q of 45. So this is 100 minus 45, right? 100 minus x times 40 plus 4 times 45. So if I work this out, 100 minus 45 is 55. 40 plus 4 times 45, well, 45 times 4 is 180. Okay? And 180 times plus 40 is 220. So if you don't know what the answer is, if you can't use a calculator on your exam, then this is reasonable. You can leave your answer here. That's why I showed you this. But if you're allowed to use a calculator, then 55 times 220 is 12,100. And that would be the solution to problem number 16. Any questions here?
Yes, I have a question.
Sure.
On my simple exam is like math 172, but they are like completely different questions. They are not those kind of questions.
That's okay. Well,
the
we
reason
did listen, we did most of them. There's some questions that I know that are not there. Like the trig questions. The last question I think was 18 or 17, where you have to do an construct an exponential equation based on the word problem, an application base. We can go over that in the Math Center. The Math Center is available from Monday through Wednesday. We're opening at 11. The closing time can vary. So we have to go day by day on that one. But come to the Math Center. I'm located in Gillette, room 233A.
Room 233.
A, that's right.
At what time? 11 until what time?
Again, the time that we close will vary. So like on Monday, we will close at 7. On Tuesday and Wednesday, we might close before 7. We might close way before 7 because I have to do obviously the Wednesday workshop at 6. So, and then I'm doing a Tuesday workshop for statistic at 6. So that's why we'll be somewhat closing early on those 2 days. So best bet is come in on Monday if you can.
And you start at 11, right? 11 in the morning.
Mm-hmm.
Okay, thank you.
All right. Let me stop the recording now. So that way we could